This is a video to help with problems like this where you have a box stacked on a box, stacked on a box, stacked on a table, and you're asked for all of these different normal forces that are applied. And so in this particular problem, I called box A 2 kilograms, box B 1/2 kilogram, and box C 3 kilograms. And probably the method I'm going to use is to draw a free body diagram for A, a free body diagram for B, and a free body diagram for C. And some of my free body diagrams, there's probably going to be force of gravity, so a good starting thing to do might be just to use that model for force of gravity, that gravity pulls 9.8 newtons for every kilogram. And so we said that force of gravity is 9.8 newtons per kilogram times mass. So if I do the force of gravity on A by Earth, then I'd sub in A's mass, which is in this problem 2 kilograms. The kilograms will cancel, and I'll get 19.6 newtons. And if I do the same thing for force of gravity on B by Earth, I'll get 4.9 newtons in this case. And if I do force of gravity on C by Earth, I'll get 29.4. And I'll just have those up there so that later when I need them, I can do them. But first, let's start with A. This is A. A is my object. It's touched by another box. If I circle it, I can look at what touches it, and it looks like box B touches it. So there's a normal force up, F normal on A by B. And of course there's more boxes below and the like, but I'm just looking at A, and what touches A is just B. So there's this force away from that surface. There's also a planet nearby, so I can say that there's force gravity on A by Earth. And that was why I went ahead and solved for that. I knew I need it. It's that number right here, that 19.6. Since it's not accelerating, we can say the forces are balanced. We can either say F net is the up force minus the down force and sub into there and say I don't know my up force. I do know my down force. And my unbalanced force, since it's not accelerating, must be 0. There's no unbalanced force. Or you can just look at it and do that hash mark thing and realize, oh, the force normal on A by B must be 19.6. So we're set with A. We know the normal force on A by B. Now we're going to come around to box B. I'll draw box B here. And box B is my system. We know that there's box A above it and C below it. And then, of course, there's a table and so on. But I'm only interested in B, so I'm only going to circle B. And the things that touch B are box A and box C. So I'll go ahead and draw a free body diagram for B, and I'll say box A is a surface above it. It must push down. So there's this F normal on B by A. C is below it. It must push up. I don't really know how big, so I'll just draw sort of random. F normal on B by C. I don't know how big either of those are. And then of course there's a big planet nearby, so I'll make that a little bigger so I have room. And I'll draw another arrow down to be F gravity on B by the Earth. And that's about the only one I know so far. That's 4.9 newtons. Now I do notice that this has F normal on B by A, which reminds me that back in diagram 1 I have F normal on A by B. That reminds me of Newton's third law. Newton's third law says whenever object A puts a force on object B puts the same force on object A but the opposite direction. So if B pushes A up, then A pushes B down with the same amount. B pushes up on A 19.6 newtons. That must mean A pushes down on B 19.6 newtons. And now I have my two down forces, so I can solve for my up force. F net equals my up force minus my down force. Because it's balanced, there's no net force. I don't know my up force, but I have two down forces. I got 4.9 down, I've got 19.6 down, and so when I solve for my up force, I'm going to get 24.5 newtons. So that helps me figure out the normal force on B by C. Looking at the idea that this force is the same as this force by Newton's third law. Now I'm going to go for C, and I did not leave myself enough room, so let me do C down here, the FBD for object C. This is object C. There's a little box above B. There's a table below. If I circle C, that shows me that there's two objects that push on C. So I'm going to have two normal forces. There's a table below that's going to push up, F normal on C by table. And box B is above, it's going to push down with the surface force, F normal on C by B. Those are the only things touching it. We know gravity can act without touching it. I'm going to make that a little wider so I can squeeze in F gravity. And I don't know how long to make it, so I'll just sort of draw it random, but F gravity on C by Earth. Oh, I take that back. I do know how long to make it. I solve for that up here. That one's 29.4. And then I'm stuck with two unknowns until I look at it and go, wait, normal on C by B, I bet that's the same size but the opposite direction as the normal on B by C, which I solved for here. C pushes up on B 24.5 newtons, so B must push down on C 24.5 newtons. And then I can do a similar thing that I did in the last problem, which is to say that F net is the up force minus the down force. It's balanced forces, there's no unbalanced force. I don't know my up force, and I have two down forces, 29.4 and 24.5. So when I finish solving that all out, my up force works out to be 53.9 newtons, and that's the normal force on C by the table, 53.9 newtons. And again, we got that by saying the normal force on C by B is equal to and opposite of the normal force on B by C. So we had to utilize Newton's third law along with those net force equations. Hope that helps.